That's a novel way of choosing whose turn it is. But whose turn for what? That's impressive. That's really impressive. Working out is obviously easy in a weightless environment. Let's see you try that on Earth. Not so easy, but I guess that's the difference between mass and weight.
You might think this has something to do with weight. Well, you're nearly right. Not just weight though, but mass. Mass is the amount of matter in an object. Weight, however, the feeling of something being light or heavy, is caused by gravity acting on the object.
Pedro and Alexander are floating in the ISS. Because gravity has no effect, they feel weightless, even though their mass is the same as it is on Earth. You can see Pedro lifting another astronaut, Umberto Guidoni, here on Earth. Umberto's mass is not that much different to Alexander's, but because he's on Earth, what Pedro's feeling is his weight. So, how does mass come into the second law? This science stuff is very serious. One ball is wooden and the other is brass. This time we have 3 balls. We're adding a ping pong ball. You can see here that things with more mass move more slowly. The second law says there's a connection between force, mass, and acceleration. So, if you apply the same force to objects of different mass, they will accelerate differently. Exotic, a stream with a steady current. There's 1 floater versus 5. I wonder who's going to win. Less mass means more speed. He's way faster. A force is applied, and according to the first law, she should accelerate. Okay. We add a heavy bag, and she seems slower, plus she hasn't travelled as far. This is just like the ISS experiment. That's not a fair race, guys. Here we have magnets set up to repel each other. Magnetism is a force, isn't it? It looks like the skate carrying the load is travelling slower, and that makes sense. More mass means less velocity when the same force is applied. So, Newton's second law states that force is proportional to mass and acceleration. So the greater the mass, the slower an object will accelerate when the same force is applied. Pedro blows the balls with the same breath, but their different masses mean they move at different speeds. Newton's second law is easier to demonstrate on the ISS, but here on Earth there are other factors to complicate things. You might be thinking that the single one will land first. In the other experiments, the lighter object travelled faster, but they land at exactly the same time. We've got a crumpled page and a regular page. They've got the same mass and they're dropped from the same height, so they should land at the same time, right? But no. One of these factors is friction. Friction is the resistance between surfaces as objects move against each other. It causes objects to slow down or stop. If there was no friction, they would keep going. This complicates proofs of Newton's laws, especially because different surfaces create different types of friction. This is why we skate faster on the ice or in a smooth corridor. So, what about the papers? Was there friction acting there? Well, there was friction between the objects and the air. It was due to friction that the flat page landed after the crumpled page. The flat paper has a greater surface area and is slowed down because it experiences more air resistance. If this experiment were conducted in a vacuum, the 2 pages would land at the same time. But why did the sack of apples land at the same time as the single apple? Well, that's down to a unique feature of gravity. The sack of apples, with a greater mass, and the single apple with less mass are both attracted by Earth's gravity. But gravity pulls more on the sack of apples than on the single apple. But if something has a greater mass, it needs a greater force to accelerate, right? So that, in the end, both have the same acceleration and hit the ground at the same time.